This lesson is called slope fields, and essentially we need to find the gradient, or y dash. We need to use dy dx or y dash, which is just this, to find the subject and to find the gradient at points to create a slope field. Now, slope fields, I reckon we should call them gradient fields, but I don't get to choose the name. But essentially, we're looking at a gradient at certain values as well. So the best way to do it is just do an example. So here we go. Okay. So the first example is create a slope for this. Okay. So what we need to do is draw a table of values. Well, I'm going to draw a axis first, okay? And I'm going to go 1, 2, 3. Well, that's not good. 3, and we can even go 4. -1, -2, -3, -4. And we'll go 1, 2, 3. 3, 4, -1, -2, -3, -4. If we get to that, what happens? Okay, so what's the gradient when x equals 1? Okay, what does dy dx equals? It's going to be a half. Okay, let me do this. When x equals 1, dy dx equals a half. So we're just substituting into there. When x equals 2, dy dx equals 1, because it's going to be 2 over 2. And I think I'll leave it at that. I'm just going to go, when x equals 0, dy dx equals 0. And I'll do one more when, so I don't need this bit here. We can put it in, but we don't need it. So when x equals -1, dy dx will equal -1/2, and when x equals -2, dy dx will equal -1, because it's going to be -2 over 2. So all we're doing is just substituting into this thing. Now, each one of these is a gradient, okay? So I'm going to start with this one. When x equals 0, dy dx equals 0. Okay, so at x equals 0, so this is x over here, and this is y, all right? At x equals 0, which is this whole thing here, all right? That's all the points x equals 0. Dy dx equals 0, so the gradient equals 0. So I'm going to pull this. And this is our slope field. Can you see it's just horizontal? Because when you have a gradient of 0, it means that there is no slope. Because remember, gradient means slope. And I'll put that one down the bottom. Okay. Now I'm going to work my way across. At x equals 1, our gradient is a half. So at x equals 1, our gradient is a half. So it's going to have a positive slope, and it's positive, so it's going to be like that. Probably a bit more shallow. So I'm going to do this. At x equals 2, the gradient is now 1, so it's going to be a bit steeper than the one before, so we're going to go up. And essentially we're trying to do the same thing for all of them. This is what the slopes are, okay? We'll leave the other ones there. Now, what you can see is that x equals -1 is going to be exactly the same as this one, but just of negative gradient. So it needs to look a bit like that when we draw it. We need to be pretty accurate in our drawing of it. More accurate than even my drawings are. And then same again, at x equals -2, the gradient is 1, so I need to sort of get it going. So you can see why this lesson is called slope fields, and you can see why I've called it gradient fields, because in actual fact, we're looking at gradients here. Okay? And then what this does is that it describes a function, all right? So if I were to integrate this one here, both sides, I get y equals x squared on 4, okay? Which is actually just a parabola, and there'll be plus c if I were to integrate it. And you can see that here we have these slope fields are describing different parabolas that are getting drawn, okay, up and down. I drew really bad, but you can see that it has this basic shape, and there's heaps of them that you can describe for. All right, so that's one example. Here is a second example. Now we're not testing for x, we're testing for y. So I'm going to do the same thing. I'm going to draw an axis here. And I'm going to do the same thing. And because we're going to substitute in y's, I'm going to focus on that for the moment. So I'm going to go 1, 2, let's just go as far as that. 1, 2, negative 1, 1, 2, and then let's do the same over here. Now I'm going to draw my slopes. So at y equals, let's start with 0, dy dx equals 0. So that means this is the y value and that's our x value. That means at the point y equals 0, which is here, okay, it's the x-axis is y equals 0. The x-axis occurs with y equals 0. All of the gradients are 0, so we're going to put that in 1. See how a gradient of 0 means a flat sort of line. Now let's keep going. At y equals 1, okay, now you can see my axis is off, so please do it better than what I did. Dy dx will equal a half. So now we've got a little bit of a gradient there, okay. At y equals 2, dy dx will equal 1 because it's going to be 2 over 2, which means it's got a bit of a steeper gradient. It's a gradient of 1, so I need to note that, okay. And you can see the field starting to set place. At x equals negative 1, dy dx will now be negative a half. So now we're going the separate direction, we're going negative direction, and it's almost got to look like this one, but just the reflection of it with the x-axis being the mirror. And then you can probably see that at x equals negative 2, dy dx will equal negative 1. And so we've got to make that known. So it's got to be the reflection of the other one. Now we've got to, this one's probably a bit wrong because it looks like the other one. It's got to look like it's a steeper gradient. Okay. And now you can see the fields that are created here. And this one's a bit different. It goes like this sort of thing. So it's like an exponential graph and stuff like that. And if you integrated it, you'll get why that's the case as well. So here's a slope field for that. Finally, I'm going to create this one. We're going to have to do something a little bit different. Now, first of all, I need dy dx or y dash to be the subject. So I'm going to move this over to the other side and we get y dash equals minus x. And now I'm going to divide by y. Therefore, I've got this as the subject. The issue is I have both x and y. So before I can draw something, I need to do some sort of table of values of sorts. And this is what it will look like. I'm not going to put heaps of values in. So I'm going to go... that should be plenty. So these you'll see often, and you've got to split it up in here. And what you do is you've got x and you've got y, and I'll start at negative 2, negative 1, 0, 1, 2. And here I'll do the same thing, negative 2, negative 1, 0, 1, 2, and I'll leave that bottom one out. Might even get rid of it. Let's get rid of it. Okay. So, and let's fix this up. All right. So, in essence, they're looking at the point when it's x and y, and we're going to draw some sort of slope. So, if we look at substituting into this one, all right, you'll get a value. So, -2 over -2 is going to be, normally it's +1, but this negative here will make it -1. So, it's going to have a slope like that, okay? Now, this one will be 1 over 2, and it'll be negative, so it's going to be -1/2, which is that. When x is 0, it's just going to be 0, because it's going to be at the top. 1, well, we're going to start going up the opposite round, and 2 will be a bit further up, all right, because it'll be 2 over -2, and it becomes +2. Now, -2 over -1 is just going to be 2, but it's going to be the opposite side, so it's going to be a bit steeper than above. So a bit steeper than above. And then this is going to be -1 over 1, which will be the same sort of thing, but just like here. 0, anything 0 will just be 0, okay? I've got to be careful with that one. I'll explain that one. Well, I'll explain it now. Why? Because at the bottom, it's at the denominator, we know that that can't be 0, so this is going to be undefined, okay? So it's essentially there's going to be like an asymptote that goes through here. All right, let's keep working with this box here. So we're going to get 1 over -1, and it's going to be +1, so it's just going to be like that. And then 2 over -1, it's going to be negative, but it's going to be positive, so it's going to be like that. Okay? Now, at the bottom, it's going to be a similar thing. So it's going to be 2 over 1, and it's going to be positive, though. So it's going to go like that. So it's going to be +2. This is going to be 1 over 1, but it's going to be, so it's going to go like that. And then we've got 1 over 1, but it's going to be negative, so it's going to mirror it out, and we go there. Now, the last one, we've got the last row. -2 over 2 is just going to be 1, and it's going to be a +1, so there, which is a little bit more like that. -1 over -2, so it's going to be positive, but a bit like the slant is going to be a bit less, and then obviously the other side is going to mirror it going like that. Okay, now let's just draw that on a graph. Let's draw it on a graph. It's going to be 1, 2, 1, 2, -1, 2, -1, 2. And I'm just going to fill in the bits as you see. I'm probably going to fast forward this bit because I feel like I've been talking too long.